let's look at this integral. An integral of x to the power 4 into 1 minus x to the power 4 over 1 plus x squared dx from 0 to 1. How can we handle that? And we show that it is equal to 22 over 7 minus pi. We are supposed to show that. Okay, let's go right away. So the first thing I'm going to do is to first work out this, to simplify this statement here. Like if you have x to the power 4 into 1 minus x to the power 4 over 1 plus x squared. I'll first simplify this, then I'll bring in the integral later on. So I want to write this in this form. I'll introduce in minus 1, then I remove it. By putting a negative 1 and adding a 1, it changes nothing, but it is just for purposes of simplifying the integral. So this will be over 1 plus x squared. Okay, so you'll see that if I expand, I'll take this like x power 4 minus 1 with this, then the 1 will also go with this. So I'll have x power 4 minus 1 into 1 minus x to the power 4, then also this plus 1 times this, which is a 1 minus x to the power 4, then over 1 plus x squared. So if you look at this, if I simplify this, you look at this, I can write it as a difference of two squares, and it will be like x squared minus 1 into x squared plus 1, okay, then times 1 minus x to the power 4, then plus the 1 minus x to the power 4. So divided by 1 plus x squared. So you see this one will go with this because this and this are the same, but this one can further be reduced to a difference of two squares, like x minus 1 into x plus 1, then times this 1 minus x power 4, because this one goes with this. Okay, then this one will remain with 1 minus x to the power 4 over a 1 plus x squared. Alright, we are there. So I can further simplify this. This is always to simplify this expression so that at the final step I just integrate. It will be easier to integrate. So this expression here, this one here, I can simplify it further so that when we take it to an integral, it will be easier to integrate. So let me first consider that again. So that expression is x minus 1 into x plus 1, then into 1 minus x to the power 4. You see this is the same as this, like this one has a power 1, so I can write it as actually I can make this the same as this. Like if I take out a 1 here, it will be like x minus 1 into x plus 1, if you take out a minus 1, I just want to make this the same as this, x minus 1. So when you take out a minus 1 here, this will be negative 1 to power 4 into 1, sorry, it will be x. This will be x minus 1 to power 4. I just wanted to make sure that this is the same as this. So after, now I can consider indices when the base is the same, we add the powers. So I'll have x plus 1 into, of course, negative 1 to power 4 to power this even number, it is a 1, so that will be 1. So this one remains x minus 1 to power a 5, sorry, it is to power 5. So further on, I can further expand this in the form like, let me first bring this bracket first. Now this bracket, I can write it in this form like x plus a 2 minus a 1. So that if I reorganize it, it becomes x minus 1, like that, then plus a 2. I've changed nothing. It is just all about simplifying this so that when we go to differentiation to integration, it becomes a bit easier. So when we expand this, this will be like x minus 1 to power 6, because the base is the same, then plus a 2 into x minus 1 to power a 5. So I'll leave that there. Now I think you can see that when you integrate this, it is a bit easy. Now I've remained with this. Now let me go to this. How can I simplify this? So to simplify that, it was 1 minus x to power a 4 over 1 plus x squared. What we are going to do, we expand this numerator, and when you expand it, you end up with x squared, I mean x to power 4 minus 4x cubed plus 6x squared minus 4x plus 1 over 1 plus x squared. Now I'm going to group these into two parts, like I want to separate this numerator into two parts. So I'm going to group, I'm going to take these ones that have x with powers that are even and the 1, and then I bring these ones that have odd powers also together. So this one will be like x to power 4 plus 6x squared plus 1 over 1 plus x squared, then plus this minus, like plus, this one is negative 4x cubed minus 4x over, like they are sharing the denominator. Actually, by separating, I realized that somewhere when I factor out a negative 4x here, the numerator will be the same as, there will be a factor that is common to that of the denominator, and they will cancel out. So like you have this one remains plus 6x squared plus 1 over 1 plus x squared plus factorize out a negative 4x. In the numerator remain with, this will remain x squared plus 1 over 1 plus x squared. So now you can see that this one and this are the same. I can cancel them out. Okay, now further I can write this in a simple way by long division. You will see that when you divide this by this, you get something and the remainder. There's a quotient you get and then the remainder. So we need to express it into that form so that it is easy to integrate. At this point is difficult. Now this one is simplified because when you have negative 4x, this is very easy to integrate, you know. But now we have this. This was made easy. This one has been made easy. Now we have this. Okay, so let's simplify this. You use long division, and when you use long division, you realize that x to the power 4 plus 6x squared plus 1 over 1 plus x squared. This one will give you, it will give you x squared plus 5 as the quotient, then minus f4 over x squared plus 1. So this has been broken down, okay, into small parts just for simplicity. Now we can bring it back together from the start. Like if you've been following keenly, you see that x to the power 4 into x to the power 4 into 1 minus x to the power 4 over 1 plus x squared is equal to the x minus 1 plus 2 into x minus 1 to the power 5. This one comes from this here. Okay, and then plus, we just add up those small terms that we got. This was a square, squared plus 5, then minus 4 over x squared plus 1, which is this. Then there was a minus 4x. So when we integrate this, we are integrating this. Okay, like from 0 to 1, we can now bring in the integration. We broke it up into smaller chunks just to make it easy at the point of integration. Like when we integrate now with respect to x from 0 to 1, from 0 to 1, like we can differentiate partly. Differentiate this, integrate this, integrate this, integrate this with respect to x. What do we get? Okay, so you see we end up with this one, since when we differentiate the function in the bracket, it gives us a 1 which is x outside here, which is it means that the derivative of the bracket or the function in the bracket is outside. So we just raise the power here, so this will be x minus 1, raise the power and then divide by the new power, then plus, do the same here, because when we differentiate this in differentiate x minus 1, we get a 1. There's a 1 here, silent 1 here, don't mind about it, it's a constant. So we do the same, raise the power of this by 1, giving a 6 over 6. Then do the same here. This is x cubed over 3. This one will give you 5x. Now this one, you see that is a tan inverse, like leave around out a 4. It means you have 1 over x squared plus 1. So when you integrate it, you know it gives us a tan inverse of x. Now when you integrate this gives us minus 4x squared over 2. The limits are from 0 to 1. Okay, so let's feed in the limits. When you feed in the limits, if we substitute a 1 throughout, these ones will go. Because this is a 0, this is also 0, they will go. Here we'll have 1 over 3 plus this will remain a 5 minus this is a 4. Now the tan inverse of 1 gives us a 45, but 45 is the same as pi over 4. Since in our proof what they need is having pi, we can divide by, we can change it to pi instead of leaving the 45. Then what about here? This is 4 divided by 2, so remain with minus 2. So this is one bracket, so we subtract off. Yeah, when you subtract off, now feed in a 0. When you have a 0, this will be 1 over 7. There's a minus because 0 minus a 1 is a negative 1, and because the power is odd, then this will remain a negative. Then this one will be plus 1 over 3. Then the rest will go to 0. So when you expand this, this will be like 1 over 3, 5 minus a 2, that is a 3. This one will be remain a minus pi. Okay, when we bring in this will be plus 1 over 7 minus 1 over 3 plus a 0. So this will go with this. So you remain with this. Which gives us, remain with 3 plus 1 over 7 minus pi. Okay, so when we simplify this, if I try to make this with the denominator 7, this will be 21 over 7 plus 1 over 7 minus pi, which gives us 22 over 7 minus pi as required. Yeah, so that is it. Thank you for watching. Don't forget to subscribe and share with your friends if this has been important to you.